Hey guys, my name is Mike, and this is Math Tutoring with Mike. Hey, before we jump into our video, there are just a few things that I would like to review with you. The first thing is that I want to implore that at the end of this video, by the time that you reach the end of this video, I want to make sure that you understand the principles that we went over today in this video. So if you have to stop the video at any point in time, that you're confused, or if you have to rewind, I really want to suggest that you do that. The second thing is that after you've reached the end of this video, that you actually go back and try solving the example problems on your own. Doing this, I find, is very important with cementing the theories and cementing the understanding, that you actually understand what was reviewed. So, thirdly, chances are you came to this video with a specific problem that you had. If at the end of this video you realize that I have not addressed the specific problem that you are looking to solve, I invite you to leave me a comment or shoot me an email with your specific problem or specific question. And you have my word, I'll do my best to either preparing another video or reaching out to you personally how to solve that particular problem. Anyway guys, so on to our video. Today we're going to look at how to add fractions. When we think about adding fractions, there are two types of problems where we could see when we're adding fractions, and that is when fractions have the same denominator That's one situation. The next situation is when fractions have different denominators. So we're going to take a look at both situations, how to add fractions with the same denominator and then with different denominators. And as you recall, the denominators are at the bottom. So this is the numerator and this is the denominator. Okay, let's take a look. So when we have fractions that are with the same denominators, it's very simple. All we have to do is keep the denominators, which in this case is 3, and we take both numbers and we add them together, 2 plus 1. And in this instance, it would be 3 over 3. And 3 over 3, as you know, it is 1. And it makes sense, right? 2/3 plus 1/3 is equal to 1. Okay? If we have 3 fractions to add, and if they're with the same denominators, it's the same situation. Okay? Since the same denominators, then we would have 3 here, and then we would bring down each one on the next line. It would be 2 plus 1 plus 2. And that would equal 2 plus 1 is 3, is equal to 5 over 3. Okay, so it's very simple. If you have 2 fractions, 3 fractions, 10 fractions, you apply the same principle every time by adding fractions with the same denominator. But what happens if the denominator is different? Let's see, how do you solve that? So if you have, let's say 2/4 plus 1/3. How do you add those fractions? Well, the first thing you want to do is you want to find what's called the lowest common multiple. Okay? So you want to find the lowest common multiples of the denominators that we're looking at. Okay, and in this instance, it's 4 and 3. So we want to find the lowest common multiple of 4 and 3. And I actually made a video showing how to calculate or find the lowest common multiple. But to find it, you want to list all the multiples of the denominators that we're working with. And in this instance, it would be the 4 and the 3. So we would have take the 4 and we'd find the multiples of 4. It would be 4, 8, 12, 16, 20. And if you notice a pattern, 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, 4 times 5 is 20, so forth, so on. So knowing your multiplication table is very important in this step. And similarly, we find the multiples of 3. 3 times 1 is 3, 3 times 2 is 6, 9, 12, 15, 18, 21, and so forth, so on. So once we've found all the multiples of 3 and 4, we then want to circle or identify all the common ones. And in this list, we can see that the common one is 12. Guarantee that there will be others if we had kept on expanding our multiples list of 3 and 4. So when we expand that list, we can see that our common multiples, if we were to highlight in blue, our common multiples would be 12 and 24. So we say our common multiples, 12 and 24, and our lowest common multiple then would be the lowest number of those, which would, in this case, be 12. So now what do we do with this 12? We now want to take it and we want to put it, we want to assign it in this location in our next step of where we're solving the problem. So get an eraser, whatever the lowest common multiple value is, we're going to then put it there. So the next step or next thing that we do now is we want to now work with each fraction represented in our problem. So I'm just going to put a number so we can easily identify for later. And let's look at the first fraction here. 2 over 4. And we ask the question, what number when multiplied by 4 gives us 12? Well, 4 times 3 equals 12. So then we take the 3 value and then we put it in our numerator. And then we ask 2 times 3 is equal to 6. This 6 value now, we want to now take this 6 value and we want to now put it in our first position here. We want to bring down our addition sign, and now we want to solve the equivalent fraction for our second equivalent fraction, which in this case is 1/3. And we ask the question, 1/3, our denominator, we look at our denominator for second fraction, and we ask the question, 3 times what number gives us 12? And we see 3 times 4 equals 12. Whatever number we found in our denominator, we put the same number in our numerator, and we ask the question, 1 times 4 equals 4. Similarly, like we did in our first fraction, now we want to take this 4 and we want to put it here. And now we see that we can now solve our problem. We have 6 plus 4 equals 10 over 12. So 2 over 4 plus 1/3 equals 10 over 12. we would notice that with enough mathematics, we would notice that this can be broken down more into to 5/6. But 10/12 is also a correct answer to this problem. Why don't we look at another problem where we're adding fractions? This time we're going to add 3 fractions instead of 2, just so we can see that we can apply the same principle when adding 3 or as many fractions as we want to. So we have 1/2 plus 2/3 plus 3/4. Just random numbers that I wanted to choose. Okay, and we would see that in keeping with our approach here, the first step we would need to find is our LCM, our lowest common multiple. So now we want to look at all the denominators of all 3 fractions, and we want to find the common multiples. We want to find all the multiples at first for all the fractions. It would be 2, 4, 6, 8, 10, 12, 14, and I would encourage you to list out as many multiples as you can. I'm sorry. Should be 18, 20, 22. So 4. Multiples of 3 is 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. And for 4, it's 4, 8, 12, 16, 20, 24. And I'm doing all of this, because I'm so used to my multiplication table. It's just like I was showing in the last example. 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, 4 times 5 is 20, so forth, so on. Okay, so knowing a multiplication table is very important here. So now that we have listed out as many multiples as we possibly can, the next step now is identifying all the common multiples between all the 3 numbers here. We see that 12 is pretty common. We see that 20, 22, 24. Actually, 24 is another common one. You see the next number that would be, in our multiples of 2, would be 24. So all the common multiples would be 12 and 24. And our lowest common multiple, actually, let's put it here. Our lowest common multiple would then be 12. So we take the 12 here, and we then put it here. Our lowest common multiple is 12. So now that we have identified what our lowest common multiple is now, our next step now is we want to take a look at all of the fractions that we're trying to, that we're working with here. I want to put a number to them just to identify, easy identification, and not to get lost at all. So the first one is 1/2. Okay, we look at our denominator and we ask the question. Keep in mind this 12 here is the lowest common multiple that we just found. So 2 times what number gives us 12? The answer is 6. 2 times 6 is 12. So then we take that 6 and we put it in our numerator, and we say 1 times 6 is equal to 6. So this first 6 now we want to put it here. Bring down the plus sign. And you know what? Just to save time, I'll also bring down this plus sign. But we know that a number has to go here and a number has to go there. Okay? So our second fraction we want to work with now is 2 over 3. So we look at the denominator. We will look at the denominator, in that fraction. And we say the denominator is 3. 3 times what number gives us 12? And once again, this 12 is the lowest common multiple that we found a while ago. So 3 times what number equals 12? And you see that the answer to that is 4. 3 times 4 equals 12. So then you take the 4 and you put it in our numerator. And you say 2 times 4 equals 8. So then you want to take this 8 and we put it, the 8, actually we put it here, okay? Just to show you where it goes. 8. Finally, we look at our third fraction, and we say 3 over 4. We look at the denominator, and we identified 4 times what number gives us 12. And once again, this 12 is just our lowest common multiple that we found earlier. I hope you guys are seeing the pattern here. So 4 times what number gives us 12? You could see that the answer is 3. 4 times 3 is equal to 12. So then we take this 3 and we add it to our numerator. And we ask the question, 3 times what number? 3 times 3 is equal to 9. Similarly, we take now the 9 and we put it here and this number there. So now we have all 3 numbers because it's 3 fractions. So now we proceed to the next step. 6 plus 8 is 14. 14 plus 9 is 23. And we see that our answer is 23 over 12. So you've made it to the end of the video. Good deal. I really hope that you understood what was reviewed today. Like I said earlier on in the video, I really think it's a good idea that you go back and try to solve the example problems on your own. That way you can prove to yourself and you can help assure that you actually understand the problems. Well, until next time, with another tutoring session, another math tutoring session with Mike. See you guys.